My name is Stephen Burr from Wadio. Today I wanted to take you through a quick demo, something we pulled together to extend what we had presented at the recent ARM TechCon event in November. And so what I wanted to do today is to extend that and show how we could take the same valuable data service integrations but connect it up to device data that was coming over MQTT. And so in today's example, we're going to show how MQTT-based devices can connect up to a Wadio adapter acting as an MQTT broker. We could also have an MQTT adapter acting as a subscriber if you have an existing MQTT broker. And then, of course, we'll take those messages just like we would any other Wadio messages and route them to Elasticsearch and ThingWorx, BitBio, and scriptr. We'll take you through those as well. So what I have here is just a simple little simulator script that is going to connect up to an MQTT exchange and publish some messages at a random interval. In this case, I'm simulating some GPS data, some latitude, longitude, and a temperature. And I am sending that along with a device ID and a timestamp every few seconds. And so if I go ahead and run that with a device ID of this GPS MQTT1, the default interval is every 3 seconds. And you can see that I'm sending these messages. Now, if we go back to our diagram, you can see that in this case, these red lines are communicating over MQTT protocol, and then that protocol gets translated into Wadio's internal AMQP protocol and routed to the appropriate data services. So we can see what's happening here. Even though we connected to the MQTT topic called demos, MQTT devices, data, and then the device ID, you can see that if I look at the AMQP resource called MQTT devices, I'm also getting those same messages here. And because I have set up these additional routing rules, I can look at those paths as well. So in this case, I'll look at Elasticsearch, and here I'll look at my ThingWorx messages. And you can see that each time one of my messages comes in, it's getting fanned out to these additional data services. And you can see that I've, in my adapter for Elasticsearch, for example, I've actually transformed this message into an insert message to insert the message into the appropriate Elasticsearch index. And in the case of ThingWorx, I've converted the message into an update for my thing. So you can see those messages that are coming through here. So we're going to go ahead and take a peek at Elasticsearch just to verify that these messages are in fact coming through. You can see I've got this a number of indexes set up here. In this case, they're going into the location geo index. I've got about almost 3 million messages that have been indexed already. And go ahead and look at the index. I'll sort by my timestamp. And you can see that I've actually got a number of different kinds of messages that are going into the same index. And that's because I already had a number of other messages that were going into this Elasticsearch data service. I just added some new devices in and routed them to the same adapter, and I get all of those messages indexed here as well. So I've got some traffic disruptions, I've got some street signs and locations of traffic cameras, and then I've got my GPS MQTT1 messages as well. And of course I can go in and I can do ad hoc queries. If I change my index, I can look for any of these fields here that are being indexed. Elasticsearch also comes with a visualization dashboard called Kibana. And in this case, because we have geospatial data that's being indexed, I can display that in a map. In this case, I've got what I had already for my ARM TechCon-based demo. We saw that we had traffic disruptions and street signs and traffic cameras that were being indexed. Well, here you can see that those are actually coming from the London, England Open Data Project, and those are the locations of street signs and traffic cameras that are being indexed in real time. So this is actually a heat map histogram of the number of devices that are in each geographic area. But we weren't sending it to our messages, our simulated messages, if you recall. We're over here in the 42 minus 78 region, latitude and longitude. So let's zoom back out and we'll show that this same index in Elasticsearch contains both data sets, because those messages are centered around our Buffalo, New York office location. And so you can see if I zoom in to the appropriate level over here, I can see where these devices are reporting as well. And so this is Elasticsearch and a visualization of a query capability on top of these search indexes. What if I wanted to build up a different kind of application, maybe an interactive application or a dashboard? Well, maybe I would use ThingWorx for that. So in ThingWorx, I can model my domain space as individual things. Each thing can have its own properties. So if I look at a thing I've created here that has the device ID of my simulated device, I can model it with properties. I can give it a location and a device ID. And so our integration is actually sending our messages at this thing, and that's populating these properties in real time. And so what we're able to do with ThingWorx, in addition to simply populating this, is we can store the history of these values. We can also create a mashup application. So if I look at this mashup, you can see that again we have a map widget where we're able to plot the location of our messages as they are reporting their positions. So in this case, we've got our camera messages, and these are the actual images being reported right now from London, England at each of these traffic signals. We've also got digital signage, so these are the road signs and what they are currently displaying right now. But then if we zoom back out, of course, we can see our messages over in Buffalo, New York as well being reported for our vehicles here, and you can see the icon is different. And in this case, we can zoom in. Maybe because we have the ability to maintain the history of the messages and their positions, we can actually plot the path that that this device is taking. So in this case, obviously, it's a simulated path that's crossing over streets, but you get the idea. You can also use the Wadio extension to connect up to bus resources, and so I'll just show that really quick. In this case, we've got a couple of other widgets that are connecting up to the devices that we mentioned over here, and they're reporting their values of a location. In this case, we've got a temperature and we've got an accelerometer. But then we were also pulling in some widgets from other Wadio data services into this ThingWorx application. So here we've got a Circonus graph that's showing the battery levels of some earthquake sensors. Here we actually pulled in our Kibana application, so we can zoom in to the exact same piece. So we're actually composing multiple data services into a single mashup. In addition, we said we wanted to route the data over to BitBio. So let's take a look at BitBio. BitBio is an API workflow automation tool, and so we can see that these messages are being routed to BitBio, and I can view them. That's not very interesting. Let's see what else we can do. Maybe I wanted to add some temperature here because I want to model that I'm heating up my my device. So I can actually take a mathematical expression, I can multiply it, pick off the attributes of the incoming messages. So here I want to take the temperature, and say I want to add 100 degrees. And so now the messages are going to have that transform applied, and then I can view them again. If I just add a view here, and I can show that as they come in, I'm getting the calculated values. But let's say that I also wanted to send these to one of the 60+ data services that BitBio has integrated. So let's say in this case I want to send it off to a Google spreadsheet and log these so I can append to a spreadsheet. So let's take these same messages and let's route them to our Google spreadsheet. Populate this guy. Let's say that I just want to take and log all of the attributes that are coming in. So I'll pick off the device ID, and I want to pick off the latitude and the longitude and the temperature. And this is what I want my row to look like. Maybe I'll put that timestamp in as well. Okay, if I save that, then I should see, first of all, we can look, of course, as these messages are coming in, we can see it in the logs that they're being sent at BitBio. But then over here in my spreadsheet, I can see that, I was playing around earlier, but I can see that my values are coming in real time as the messages are sent. So that's interesting. I can do all kinds of interesting things. I can add conditional logic and so forth, branching, kinds of things that I guess if this then that and Zapier can only wish they could do. And let's take a look at our final data service, scriptr. So scriptr is a JavaScript engine in the cloud, and we're routing our IoT messages at these scripts. So I can write an arbitrary JavaScript. I get my incoming requests, and I can pick off the parameters, and then I can do any kind of business logic that I can dream up. Let's say that I want to convert my temperature into Celsius. Well, I can do the math here, and I can debug it to the log. Let's say I want to calculate the distance between some fixed point, say my office location, and the incoming message coming from the device. Well, I can implement this simple little haversign function. I can include it here and calculate the distance. I can log it, but then interestingly, I can also return a value from this script. And so here I've changed the shape of my message. I've created a brand new attribute. I've changed the value of the temperature, so I can return those to Wadio as well. Let's just take a look at the values that are coming through here, just to make sure that we are in fact calculating the temperature. You can see that the distance is being calculated as 1.45 kilometers from the office, and that'll change as we vary. That one's the same. So we vary our location 1.42 kilometers. So what we've seen here is a very powerful ability to take MQTT-based messages and send them through a MQTT adapter, acting as a broker in this case, but ultimately to get the messages onto the data service exchange and to make the IoT data actionable through data services. Thank you very much.